All right, welcome to a lesson on special equations. First, we're going to do our daily dose of Desmos skills. So again, I want you to solve this using your Desmos calculator. So go ahead and pause the video at this time, give it a try, and see if you're able to get the answer just like I will go over with you. Okay, so here we go with this one. So I'm going to highlight all the parts that can go in the calculator all at one time. So anything that I just highlighted here in yellow, we can put that in our Desmos calculator directly, and it'll give us the answer. So again, being careful, I have a negative, parentheses, 8 minus 6, close the parentheses. Now, if we want to do to the third power, we would hit our A to the B button, put in our unit. Remember, we're going to have to scroll to the right to be able to get back in line. Minus 4 times 4 plus 12. If I put that whole thing in there, my calculator is going to recognize that as negative 12. So again, I've done all the constant numbers. I know that I have 12 negatives. And then again, I'm going to circle the part that would go in the calculator separately. I'm going to do 8 minus 4a. 8a minus 4a would be positive 4a. So I could say 4a minus 12 or negative 12 plus 4a. Either of those two answers would be considered acceptable. Now, as far as today's lesson goes, we're still going to be working with equations. So I would like you to try this activator on your own. John was given 3 equations to solve, in which equation was the value of x greater than 4. So we're going to solve these 3 equations, and we want to see which answer would be greater than 4. So pause the video, solve your 3 equations, unpause the video, and then make sure you got the right answer. Okay, so looking at these 3 equations down below, equation number 1 said negative 15 is equal to 3 times x plus 12. First thing I want to do is break my equation into a left side and a right side and locate my variable, 3x. There it is. What's being done to 3x? It's being added by 12. I know that the inverse or opposite of adding 12 would be to subtract 12. It's going to cancel out the 12s. On the other side, negative 15 minus 12 in my calculator would say negative 27. And that's what 3 times x equals. The inverse operation of multiplying x by 3 would be to divide by 3. Again, the 3's are going to cancel out, and negative 27 divided by positive 3 would result in negative 9. So answer choice number 1, we were looking for something greater than 4. It's not going to be equation number 1 because that's negative 9. Equation number 2. I have down below here, 18 minus 2 times n is equal to 92. Again, break my equation into a left side, right side, locate my variable and coefficient, negative 2 times n. What's being done to negative 2 times n? Well, it has a positive 18 on that side. I know to get rid of positive 18, or the opposite of positive 18, would be to subtract 18. Again, the 18s are going to cancel out and leave me with just negative 2 times n. 92 minus 18 would be 74 in a calculator. Again, I have negative 2 times n. The opposite of that would be to divide each side by negative 2. Again, the negative 2's will cancel out and leave us with positive n. 74 divided by 2, n would have to be 37. So equation number 2 gives us 37. That would be an answer greater than 4, but let's make sure that we did equation number 3 and that there was not 2 answers. Again, break in my equation 5 equals 18 minus x. Into a left side, right side, locating my variable there. I have a negative x that I need to get by itself. Well, what's being done to that negative x? It has a positive 18 on that side. Again, if I need to make that 18 go away, I'm going to subtract each side by 18. Again, the 18s will cancel out. But here's the thing. I still have negative 1 times x equals negative 13. 5 minus 18 is negative 13. But negative 13 is not my answer because I still have to divide by negative 1 in order to clear out that negative in front of the variable. Again, negative 1x divided by negative 1 will leave me with positive x, and negative 13 divided by negative 1 would be positive 13. So equation number 2 and number 3 would both result in getting answers that are bigger or greater than 4. So that's just the basics. Today we're not going to be working on basic standard 2-step equations. We're going to be working on what are called special equations, also known as complex equations. The goal is still going to be to isolate our variables. So nothing has really changed. The only difference is we're going to have to break these problems into fractions in order to be able to use our inverse operations in order to be able to add or subtract first and multiply or divide second. So our first examples here on the board. This would be read as -15 is equal to 4 times n plus 12 all divided by 2. Now, every term on the top is being divided by 2. So we've seen this before, but when we saw these earlier in the year, they were just expressions, okay? And we broke them apart, and then we were able to combine like terms. But this is going to be a little bit different because now we're solving for a variable. So when I say break these problems into fractions or break them apart, what I'm doing is I'm going to put everything that's on the right side, the side with the variable, again, breaking into a left side, right side, anything that's on the right side, since everything is being divided by 2, I'm going to have to break it apart so that each individual piece is divided by 2. So I'm going to make it 4 over 2 times n plus 12 over 2. So again, all I did was take my numerator and my denominator of my complex fraction and break it into 2 parts. From there, now the problem's set up and we're able to solve it. Even though it's fractions, again, we know the steps. In order to get rid of a plus 12 over 2, I would have to subtract 12 over 2. And again, I'm going to use my Desmos calculator to worry about any of the hard math. Like I would not want to have to do -15 minus 12 over 2 in my head. I'm going to go to my calculator, -15 minus 12 over 2. My calculator says -21. Made it easy for me. But that's what 4 over 2 times n equals. Because again, that's going to cancel out the 12 over 2's. Again, I have 4 over 2 times n. I know that the opposite or inverse of this step in order to divide would have to be to divide each side by 4 over 2. Again, if I have a number and a variable stuck together and there is no multiplication or division symbol or addition or subtraction symbol, it is what is called implied multiplication. So when we see a number and a variable stuck together, that is a multiplication problem, and the opposite or inverse is to divide by that coefficient. 4 over 2n divided by 4 over 2 leaves me with just 1n, and then again, I'm going to go over to my calculator. I'm going to take my answer, -21. I'm going to divide it by 4 over 2, and my calculator is going to do all the hard work and say -10.5, or if I wanted to change it to a fraction, I would be able to just by hitting the button right next to my answer. Okay, but I'll leave it as -10.5 since we don't have any answer choices. So again, the first thing I want to do with these problems is break it apart into 2 separate pieces. Once I have the problem set up, I get rid of my addition and subtraction step first. I get rid of my multiplication division step second. Let's try another one together. So this one would be 10 times x minus 4 all divided by 5 is equal to 10. So again, I'm going to locate my variable. It's over here on the left side, but everything's being divided by 5. So I'm going to break the problem apart. I'm going to say 10 over 5 times x minus 4 over 5. And the whole thing is still going to equal 10. From there, well, what's being done to my 10 over 5 times x? It's being subtracted by 4/5. So again, I'm going to add 4/5 to both sides. That'll cancel out my minus 4/5. I can drop down my 10 over 5 times x. Again, I'm going to go back to my calculator. I'm going to do 10 plus 4 over 5. I can either leave it as a decimal if it's a nice easy decimal to work with. If you'd rather work with the fraction, you can change it to a fraction. I'm going to use a fraction on this one. So 54 over 5. But again, my problem's not done. I still have 10 over 5 times x equals 54 over 5. I know that the opposite of multiplying by 10 over 5 would be to divide each side by 10 over 5. And again, whatever I do to one side to cancel out and leave me with just my variable, I do the same thing in my calculator. So I'm going to take my answer, 54 over 5, and divide that by 10 over 5. And my answer is either going to be 5.4, or again, this problem I'm going to show with fractions, we'll call it 27 over 5. So even though these problems have an extra step, these are just like those multi-step questions. The first thing we want to do is how can we set it up or simplify the problem to be easier to solve. From here, that is all the different types of equations. So I'm going to read these 4 equations on my screen, but I would take a couple of minutes and at least try a couple before you get into today's assignment, because this represents one of each of the type of problems that we've covered over these last 2 weeks with our equations unit. The top one, just like the lesson you just watched, x plus 12 divided by 3 equals -5. Make sure you break it apart and then use your inverses to solve for x. The one in blue on the top right, this would be read as -6 equals n divided by 3 minus 12. Again, let's locate the variable here on the right side, start using our inverses to get n by itself. And then at the bottom, we have 1/2 times m plus 12 is equal to 20. Again, don't let the fraction scare you. You know the steps, add or subtract first, multiply or divide second. And then finally, the one in red, this is as complex as it gets, because remember, we're going to over-under. We're going to distribute and then solve the problem in red. So at this time, I would pause the video, give a couple of these try, make sure that you have enough time to try the assignment that's on the back of all of this. And when you're ready, unpause the video or make sure you're going over these answers. Okay, so first one, this top left one, where we had x plus 12 all divided by 3 equals -5. Notice, I broke everything apart. Everything was being divided by 3, so I made it x divided by 3 plus 12 over 3, and the whole thing still equals -5. The first mathematical step I did was I got rid of my plus 12 over 3 by subtracting 12 over 3. -5 minus 12 over 3 would give me -9 as my answer. I drop down my x divided by 3 right here. If I have x divided by 3, the opposite of dividing by 3 is to multiply by 3. And again, to get my answer, I would do -9 times 3 and get -27. As far as the one on the top right, -6 equals n divided by 3 minus 12. Well, this problem was already broken into the right pieces for me, so all I had to do was use my inverse operations to solve for n. The opposite of -12 would be to add 12 to both sides. -6 plus 12 equals +6. 6 equals n divided by 3. Again, if I'm trying to get this n by itself, the opposite of it being divided by 3 would be to multiply by 3. So 3 times 6, 18. 18 equals n. As for the two on the bottom, the one on the left-hand side, we had 1/2 times m plus 12 equals 20. Again, my goal was to try to get this m by itself. Well, what's being done to m? It's being added by 12. So the first step I used was to get rid of my plus 12 by subtracting 12. 20 minus 12 equals 8. 1/2 times m equals 8. The inverse operation of multiplying by 1/2 would be to divide each side by 1/2. 8 divided by 1/2 is 16. And then finally, our last question here. Again, when we over under, 3 times 2x gave me 6x. 3 times -4 gave me -12, and the whole thing still equaled 16. So if you set the problem up correctly, your first mathematical step would be to get rid of the -12 by adding 12 to both sides. 16 plus 12 is 28. 6 times x equals 28, and I know that the inverse or opposite of multiplying by 6 would be to divide each side by 6. 6x divided by 6 is 1x, and 28 divided by 6 is 4.6 repeating. So at this point, you've learned all the different types of equations you could come across in 7th grade. So at this point, make sure you get your assignment done. When you're done, let us know. And if you need any help, by all means, raise your hand so that we can help you out.